Here's page 2 of the chi-squared solutions. So we have 3 different flavors of dog food tested on different breeds of dog to find out if there's any connection between the favorite flavor and the breed. And so here's our table, and we can kind of ignore the totals, right? So it's that table. Um, a chi-squared test at the 5% significance level is performed to investigate the results. State the null hypothesis and the alternative hypothesis. Okay, well remember, the null hypothesis is that the two categories are independent. So basically we're saying dog food flavor and dog breed are independent. So yeah, the null hypothesis, or H0, is equal to dog breed and dog food flavor are independent. Okay. And then it also says to say what the alternative hypothesis is. The alternative hypothesis, written H1, is that dog breed and dog food are not independent. Okay? Dog food flavor. Okay. You don't say that they're dependent, you just say that they're not independent. Okay, and I misspelled that. You know what I mean. Okay, moving on. We are going to show that the expected frequency of a boxer's favorite food, being chicken, is 11. And the way you would do that is with the calculator, but the calculator doesn't exactly show how to do it. Sometimes on the test they're going to ask something like this because they want you to show how we get a certain expected frequency. They want to see that you can do it. So Boxer's favorite food would be the Boxer row and the chicken column. So the number that we're trying to show is 11 is the one located in that location. So we would derive that using the numbers 35 and 44 and 140. And the way we do that is 10 is going to be proportional to 35, 10 is going to be proportional to 44. Let me write it down here. So 35 over 140 times 44 over 140 times the total number of 140 is going to be equal to something. And if you type all those in the calculator, you will see that it's actually equal to 11. Okay, so I'm going to do 35 times 44. That's equal to 1540. I'm going to divide by 140. And I only need to divide by 140 once, right? And I get, what do you know, 11. Okay, so that's how you show that the expected frequency for boxers liking chicken is 11. Okay, and the calculator gives you those numbers when you put in all the data. So let's use the F and the G tables to put in this data. So we'll use edit, and then we'll go down to F, and I'm going to type in all the numbers, and to type in all the numbers I'm going to have to say that this is a 4 by 3 matrix first. So I'm going to say, hey, 4 by 3 matrix here. 4 is the rows, 3 is the columns. And for the first one, for beef and poodle, I'm going to put 13, and so on. Okay, so I just typed all this information into matrix F, and then after you type it all in, then you could do a stat tests, option C. Option C, you can get to it quicker by going up instead of down, ironically. And then you're going to say option F. To put option F in there, you need to go second, matrix, where's matrix, and then I'm going to go down to option F, hit enter, and then the expected frequencies, I'm going to put them into option G. Second matrix, put them into G. And then I go down to calculate. Calculate, enter, and then it gives me that the chi-squared value, oh, by the way, let's see, the chi-squared value is going to be 0.675, that's pretty small, and and then we're supposed to use the chi-squared value or the p-value. The p-value is 0.995, And we're going to use those to determine if we're going to reject the null hypothesis or not. Okay. Before we do that, it does say that to calculate that the degrees of freedom is 6, show that the number of degrees of freedom is 6. And remember, we have a 4 by 3 matrix. If you have a 4 by 3 matrix, the way you figure out the degrees of freedom is you subtract 1 from the 4, and you subtract 1 from the 3, and you get 3 by 2, and then 3 times 2 is 6, right? So that's how you show it. You just say 3 times 2 is 6, okay? And then let's figure out if we're going to reject the null hypothesis. To figure out if you're going to reject the null hypothesis, you take the chi-squared value, 0.675, and you compare it to the critical value of 12.59. If you go over, that means your data is not independent. Now, if you're under, then that means the null hypothesis is preserved or is maintained or valid. So we're going to say that we do not reject. We do not reject the null hypothesis. Okay? And that's because 0.675 is less than 12.59. Okay? You could also say it's because the p-value, 0.995, is greater than the significance level, which is 0.05. Okay? Alright. Number 4. 80 people were asked to identify their favorite film genre. The results are given in the table below, classified by gender. Okay? A chi-squared test at a 1% significance level is performed to determine whether the film genre is independent of gender. State the null hypothesis. Okay. So once again, we just write that H0, or the null hypothesis, is that the categories are independent. So gender and film genre are independent. And then it also says to state the alternative hypothesis, which is that the gender and film genre are not independent. Okay, so those are the two hypotheses. And then it says to show that the expected frequency of a female's favorite film genre being crime is 10.2. And the way you do that is you just look up female and you look up crime, and then you look to see which totals correspond to those. So basically, it's going to be 39 divided by the total times 21 divided by the total. Oopsie. No, I think the editing did something there. And then I multiply that times the total. So these kind of cancel out, and I get 39 times 21 divided by 80, and I'm pretty sure that's going to give me 10.2. I'm going to multiply that offline here. 39 times 21 divided by 80 gives me 39 times 21 divided by 80. Gives me 10.2. What do you know? Okay, so that's how you demonstrate it. You give them the formula like that. Write down the number of degrees of freedom. Okay, since this was a 2 by 4 matrix, the degrees of freedom are 1 by 3, which is 3. Okay, write down the chi-squared value for this data. Okay, so now we need to put it in the calculator. We go second matrix, and I think the next one that's open is like H and I. So I'm going to put the data into H, and then I, we're going to get the expected frequencies. So we go to the edit screen, and then we're going to go down to H, and then we'll just go into there, and then we'll say that we have a 2 by 4 matrix, 2 by 4 matrix, and we're just going to type in the numbers here. So I'm going to pause while I do. So you can see that I filled in the table here in this 2 by 4 matrix, and then I press stat, tests, and I go up to chi-square test, and then I'm going to give it H and I for the observed and the expected. So I do second matrix, and I go down to H so that I can type in H there. And then I'm going to do the same thing. I'm going to go second matrix name, and I'm going to go down to I. And then we'll go down to calculate and run it. And the chi-squared value is 18.98, which would be 19.0, three significant figures. Okay, chi-squared equals 19.0. And then we're going to compare that to the critical value of 11.345. It's greater. So since it's greater than 11.345, we reject. Okay? We reject. By the way, the p-value, it says is 2.759, which is 2.76, times 10 to the negative fourth, which is a super small number. And this super small number is less than the significance level of 0.01, so that also means we're going to reject the null hypothesis. Okay? Because when chi-squared is greater than the critical value, we reject. When the p-value is smaller than the significance level, we also reject. They both become less or more at the exact same moment. Okay? So that's it for page 4. Or page 3, actually. Page 2, actually. Sorry about that.